Force and pressure. Learning about force and pressure. Today, we are going to learn about how objects move with applying force and pressure on it. We can decide whether an object is moving faster than the other just by observing it or with the help of a speedometer. We know that a moving object, like a ball, rolling on the ground slows down. Sometimes it changes its direction of motion. It is also possible that the ball may slow down and also change its direction. Did you ever wonder what makes an object slow down or go faster or change its direction of motion? Let us recall some of our everyday experiences. What do you do to make a football move? To make a football move, I will kick the ball with force. What will a hockey player do to make a moving ball move faster when he is playing hockey? A hockey player changes the direction of the moving ball with a flick of the stick. In all these situations, the ball is either made to move faster or slower, or its direction of motion is changed. How do the fielders stop a ball hit by a batsman? Fielders stop a ball hit by a batsman by holding the ball and stopping it. Good. We often say that a force that has been applied on a ball when it is kicked, pushed, caught. What is force? What can it do to the bodies on which it is applied? In science, a push or a pull on an object is called a force. Thus, we can say that the motion imparted to objects was due to the action of a force. When does a force come into play? Actions like kicking, hitting, catching, pushing, and pulling are often used to describe certain tasks. Each of these actions usually result in some kind of change in the motion of an object. Can these terms be replaced with one or more terms? Suppose a man is standing behind a stationary car. Will the car move due to his presence? Suppose the man now begins to push the car. That is, he applies a force on it. The car may begin to move in the direction of the applied force. Note that the man has to push the car to make it move. From these examples, we can infer that at least two objects must interact for a force to come into play. Thus, an interaction of one object with another object results in a force between the two objects. Let us try to learn more about forces. Activity. Choose a heavy object like a table or a box, which you can move only by pushing hard. Try to push it all by yourself. Can you move it? No. Now ask one of your friends to help you in pushing it in the same direction. Is it easier to move it now? Can you explain why? Forces applied on an object in the same direction add to one another. Next, push the same object, but ask your friend to push it from the opposite side. Does the object move? If the two forces act in the opposite direction on an object, the net force acting on it is the difference between the two forces. In the game of tug of war, two teams pull at a rope in opposite directions. Members of both the teams try to pull the rope in their direction. Sometimes the rope simply does not move. The team that pulls harder, that is, applies a larger force, finally wins the game. We learned that a force could be larger or smaller than the other. The strength of a force is usually expressed by its magnitude. We have also to specify the direction in which a force acts. Also, if the direction of the magnitude of the applied forces changes, its effect also changes. Does it mean that the net force on an object is zero if the two forces acting on it in opposite directions are equal? In general, more than one force may be acting on an object. However, the effect on the object is due to the net force acting on it. Force can change the state of motion. Let us now find out what happens when a force acts on an object. While taking a penalty kick in football, the player applies force on the ball. Before being hit, the ball was at rest and so its speed was zero. The applied force makes the ball move towards the goal. Suppose the goalkeeper dives or jumps up to save the goal. By his action, the goalkeeper tries to apply a force on the moving ball. The force applied by him can stop the ball or deflect the ball, saving a goal being scored. If the goalkeeper succeeds in stopping the ball, its speed decreases to zero. These observations suggest that a force applied on an object may change its speed. If the force applied on the object is in the direction of its motion, the speed of the object increases. If the force is applied in the direction opposite to the direction of the motion, then it results in a decrease in the speed of the object. Activity: take a ball and place it on a level surface. Make the ball move by giving it a push. Now, place the ruler from your geometry box in its path. In doing so, you would apply a force on the moving ball. Does the ball continue to move in the same direction after it strikes the ruler? The direction of motion of the ball after it strikes the ruler changes different angles to its path. The speed and direction of the moving ball changes due to the application of a force. A change in either the speed of an object or its direction of motion, or both, is described as a change in its state of motion. Thus, a force may bring a change in the state of motion of an object. State of motion. The state of motion of an object is described by its speed and the direction of motion. The state of rest is considered to be the state of zero speed. An object may be at rest or in motion. Both are its states of motion. It is common experience that many a time application of force does not result in a change in the state of motion. For example, a heavy box may not move at all even if you apply the maximum force that you can exert. Again, no effect of force is observed when you try to push a ball. What happens to the shape of a ball of dough when it is rolled to make a chapati? The shape of a ball of dough when it is rolled to make a chapati becomes flat. What happens when you press a rubber ball placed on it? It gets squeezed. In all these examples, we see that the application of force on an object may change its shape. Let us say force. Make an object move fast from rest. Change the speed of an object if it is moving. Change the direction of motion of an object. Bring about a change in the shape of an object. Cause some or all of these effects. While a force may cause one or more of these effects, it is important to remember that none of these actions can take place without the action of a force. Thus, an object cannot move by itself. It cannot change speed by itself. It cannot change direction by itself. And its shape cannot be changed by itself. Summary: force could be a push or a pull. A force arises due to the interaction between the two objects. Force has magnitude as well as direction. That is all in this chapter, students. Learning is fun.